Now, thanks to new fossil discoveries and technologies, we're getting to learn more and more about the biology of dinosaurs. Some people don't need to know more than the fact that a few of them were colossal, terrifying, and vicious. But for those of us that do, the use of comparative biology, pigment analysis, and powerful new X-rays have allowed us to gain insight into specific features, such as their colors, eating behaviors, and the shapes of their tongues. Yes, that's right, the shapes of their tongues, which, for a long period of time, was something of a mystery. This is because soft, fleshy dinosaur parts are hardly ever retained in fossil form. But thanks to the discovery of some surviving hyoid bones, which are situated at the root of the tongue in front of the neck, we now have some insight. Most animals have this hyoid bone that anchors the tongue. The shape and complexity of the bone determine how free-moving the tongue can be. Scientists have discovered that nearly all dinosaurs had simple tongues that laid flat and were extremely similar to the tongues found inside the mouth of a crocodile today. Yeah, this crocodile. Go ahead and take a closer look. Nah, just kidding. Come on back. Let's take a look at some specific dinosaurs and start with the Brachiosaurus. Let me stick my neck out on the line by guessing that most of you will be familiar with this dinosaur because of its neck. You know, the one which was typically 30 feet in length. Despite its neck being its most distinctive feature, its name actually translates to arm lizard in Greek. It's common knowledge that the Brachiosaurus is one of the largest dinosaurs to ever have lived. On average, it reached 76 feet in length and 40 feet in height. It's roughly the length of 2 school buses and as high as a 4-story building. None of which were around in the era of the big guy here. Fragmentary leg bones and vertebra of even larger dinosaur species are known, but these skeletal remains are too incomplete to determine their exact size. So this guy may have been the largest dinosaur ever. A renowned herbivore, thank goodness. The Brachiosaurus is thought to have eaten up to 880 pounds of dry plant matter every day. Most of this was made up of coniferous trees, ginkgos, and cycads. This target might have been hard to hit for this dinosaur, as researchers have learned that its teeth were spoon-shaped and not ideal for chewing food. This means that the creature would have swallowed vegetation whole, as its teeth were suited to stripping it but not breaking up large chunks of plants. This, along with the dinosaur's body shape, suggests that the Brachiosaurus would have liked to feed as quickly as possible. Dinos like these didn't always make use of their ability to strip towering trees when dining. The Brachiosaurus traveled in herds, moving to the next location once they had exhausted all of the local vegetation. And I mean all of the local vegetation, not just that which hung high on trees. It's likely that the creatures supplemented their diets with vegetation at lower levels, especially after they'd done a number on all the nearby trees. This method of feasting was the most energetically appealing for this giant. By munching on lower vegetation, researchers believe that the dinosaurs saved up to 80% in energy compared to when foraging for high-up food sources. They have also discovered that the nostrils of a Brachiosaurus were on the front of its face and not the top. This is because we now know they roamed the fertile floodplains in their respective herds. For decades, it was believed that these creatures lived in deep, watery swamps. Let's look at another common misconception about a popular dinosaur. Please put your hands together for the Tyrannosaurus rex, which is arguably the most famous of all dinosaurs. Discoveries from the past 100 years have revealed that theropods had heavily feathered skin. Theropods are the family of dinosaurs to which the T-Rex belongs, so naturally, people began to think that the creature would have been covered in feathers as well. However, a study from 2017 took skin impressions from the iconic dinosaur and found no evidence of the structures required to support feathers. If a T-Rex did have feathers, they would have been limited to its back. Researchers accept that other large dinosaurs of the same family as the T-Rex have been discovered with their remains covered in feathers. An example of this would be the Yutyrannus dinosaur. But as of now, the accepted theory is that feathers weren't a common feature of T-Rexes. This makes it easier to believe that feathers were exclusive to smaller tyrannosaurids and were there as a means of keeping the creature warm. For a long period of time, researchers thought feathers were an exclusive feature of the theropod family. But this theory has been debunked. Just like the kid at camp who was kicked out of the top bunk. You know, debunked. Anyway, fossil evidence discovered in Siberia now suggests that multiple different family groups of dinosaurs had feathers. The Siberian fossils in question belong to another species of dinosaur, Calindrodromeus zebucolicus. Oh, you think I mispronounced that? Okay, prove it. Now, this dinosaur, I'll call her Calinda, had a pelvis structure superficially similar to that of a bird and was roughly 4.5 feet long, about as tall as a fridge. Since the purpose of feathers on dinosaurs was for warmth, it's quite possible that dinosaurs from cold weather climates had more feathers than their counterparts in warm weather climates. In general, bigger animals struggle less with keeping themselves cool, so it's likely that any of the large dinosaurs who lived in these warm climates had no feathers at all. Smaller dinosaurs who lived in cold climates, on the contrary, had plenty of feathers. We now even understand what some of the designs and patterns of these feathers on dinosaurs looked like, thanks to the discovery of an ornithomimus, complete with feather and skin impressions. The name of this dinosaur is derived from Greek and actually translates to bird mimic. They were typically 11.5 feet in length, nearly as tall as a giraffe, and despite being omnivorous, had no teeth. Its other distinctive features included 3 fingers, which were all unusually the same size and length, and despite their thin bone skulls, they also had large brain cavities. Their legs were extremely long, in particular their foot bones. Combine this with their toothless beaks and long necks, and yep, it must have looked a lot like an ostrich. Although they're not as big as the Brachiosaurus or dinosaurs in general, they are bigger than any other bird in the world. And it wasn't just the body limbs of an ornithomimus that made it resemble an ostrich. They also had very similar feather patterns. Their heads, necks, and lower legs were mostly bare of feathers, but the rest of their bodies were well coated in downy plumage. This is what you call a bird's layer of feathers as a whole. It's possible, like an ostrich, that the dinosaur would have used this unusual feather pattern to regulate its body temperature. Despite some dinosaurs possessing feathers like birds, on top of also being their distant relatives, dinosaurs didn't have the type of feathers required to fly for most of their existence. Feathers found in fossil impressions or preserved in amber have allowed researchers to gain insight into why these creatures weren't very aerodynamic. The structure of these feathers appears to be very simple, with a poorly defined and flexible central shaft. These feathers would have better served any dinosaur as a fashion statement, as they would have helped attract the attention of other dinosaurs. These feathers also would have had the ability to regulate body temperature. Surprised to hear that dinosaurs had ostrich-like feathers? Wait till I tell you that their prehistoric distant reptile cousins had something that looked like fur. Allow me to introduce you to the Pterosaur. Its name is derived from Greek and translates to winged lizard. Just like dinosaurs, they were initially thought to have scaly or leathery skin all over their bodies. But over the course of the 20th century, fossil examinations revealed that many parts of a pterosaur's body were furry. The wingspan of a pterosaur could reach the length of over 23 feet, about as long as a London bus. Its toothless jaw was very long and resembled that of a pelican. How could something that looks like a pelican be so terrifying? These creatures were coated in pycnofibers. Those were simple structures, feather-like in composition, but strand-like and fuzzy like fur. Further research suggests that some parts of the pterosaur's body had more complex kinds of feathers with branching strands. If this is accurate, it would be the first time feathers were found on an animal that was neither a dinosaur nor a bird. Hey, welcome to the Dino New Year's Party. Hey, everyone you know well is here. Tyrannosaurus, Triceratops, Stegosaurus, Raptor, Diplodocus. But there will also be someone new, a guest who will surprise you. You see, paleontologists have discovered a new dinosaur species that was somewhat like the T-Rex, but with a twist. These guys would rather eat a crunchy salad than a juicy steak. Hey, meet this dude. Any guesses on how to pronounce this? Duonicus sacobatri. Thanks, please hold your applause. These are herbivorous guys that belong to the Therizinosaurs. But they had one awesome feature. A feature that showed scientists that Duonicus belonged to a new branch of dinosaur evolution, about which little is known. But hey, let's go back to the dino party, shall we? Here you can see dinosaurs with different personalities. The T-Rex is a bully and toothy. The Velociraptor seems to be very toxic and moody. The Triceratops or Stegosaurus are aggressive but silent. You know, like those guys that don't touch anyone, but it's better not to mess with them. So among them all, the Therizinosaurus is a chill guy that will always help, will always keep you company at a party, and will never be annoying. Therizinosaurs lived in what is now Asia and North America during the late Cretaceous period, about 100 to 66 million years ago. Their anatomical features made them look more like predators, like the T-Rex. But Therizinosaurs were herbivores, with large crescent-shaped claws. In some species, they reached up to 20 inches. Now imagine how dangerous these monsters would have been had they been carnivorous. But they used their claws to grab tree branches and eat leaves. The Duonicus was quite large, just under 10 feet in length. A hippo was about the same size, and their weight was about 600 pounds, which is almost half the size of a horse. Therizinosaurs had a long mouth, a bit like a duck's nose, and long front paws with 3 thumbs. But the Duonicus, that has been found recently, was unique because it only had 2 fingers on each hand. The 2-fingered dinosaur discovery has sparked joy among paleontologists. Okay, 2 fingers instead of 3, whatever, you might think. But it makes a big difference. It shows how dinosaurs evolved. The latest paleontology news reports that the discovery was made in Mongolia. It was the largest preserved claw in history. Its size was about 11 inches, and it had a curved shape. That means it was like a giant banana. The coolest thing was that the claw was covered with keratin. Our nails are made from this material too. Can you imagine? Large lizards that lived tens of millions of years ago had claws with the same composition as our nails. Nature is amazing, isn't it? Do you know this crazy theory that the T-Rex evolved into a chicken and the Velociraptor into an ostrich? There must have been tons of evolutionary changes. But the 2-fingered dinosaur discovery offers us a more understandable and more detailed explanation of how dinosaurs evolved. Therizinosaurs had 3 clawed fingers on each paw, but why did nature get rid of one of them? Scientists believe that it was practical. It's possible that a paw with 2 fingers was much stronger and more flexible than a paw with 3. This way, dinosaurs could grab vegetation and branches, like chameleons do. Scientists have also suggested that the 2-fingered long paw helped the dinosaur defend itself, care for its mates, and even play. It's hard to imagine what they could be playing at. Maybe they did high fives or high twos. It would be cool if they had used those paw pliers not only for taking food, but for fighting off predators. And speaking of predators, the T-Rex had a similar front paw structure, but its small paws were useless. It would be cool if the Duonicus could box with them or climb trees. Yes, it was an herbivore, but that doesn't mean that other bad dinosaurs could bully it. Let's just think that the Duonicus was kind of weak and formidable to the strong. That's why it would be the most welcome guest at the dinosaur party. But the strangest guest at this party would be the Dinochirus, named Terrible Hands. The case of the Deinonychus shows how dinosaurs evolved from having 3-fingered paws to being 2-fingered. The Dinochirus shows that ancient lizards could evolve into a horse or something else. It sounds weird, but let's get to know this guy better. In 1965, the arms, hands, and shoulder girdle of an unknown dinosaur was discovered in the Gobi Desert in Mongolia. When paleontologists put the bones together, they got two long, creepy arms. For many years, those arms remained in the museum without a body. It looked funny and a little scary. Each arm was about 8 feet long. This is more than the tallest basketball players. Paleontologists were trying to find other dinosaur body parts in the Gobi Desert, but their attempts were unsuccessful. The Dinochirus became one of the most famous mysteries in paleontology. How big was the owner of such arms? What did it eat? How did it live? This remained unknown until 2014. According to the latest paleontology news about this lizard, a group of scientists from the Korea Institute of Geoscience and Mineral Resources has discovered other well-preserved remains of the Dinochirus. With their help, paleontologists have managed to recreate the lizard's appearance. And that breakthrough has turned out to be much cooler than the two-fingered dinosaur discovery. Are you ready? The Dinochirus was colossal, rather slow, with a horse-like head and a spine that formed something like a hump. It looks super weird, even for a science fiction movie. This new dinosaur species belonged to Ornithomimosauria, an ostrich-like species, agile and fast-moving. But not the Dinochirus. Instead of speed and agility, the dinosaur had a large size. It was 36 feet long and weighed 13,200 pounds, which is almost the weight of an adult elephant and the length of half a metro wagon. Despite its size, the Dinochirus was quite harmless. Its long muzzle looked like that of a duck or a horse. It also had no teeth. So for tyrannosaurs and other predatory giants, it was an easy lunch. And this is not just a guess. Scientists found bite marks on the discovered skeletons of this dinosaur. It seems this poor big dude met some really bad and hungry guys. But what was lunch to this strange lizard itself? It ate almost everything: soft plants, algae, small vertebrates, and fish. It sucked food from the bottom of lakes and rivers with its beak and tongue and swallowed stones to help grind the food. Those stones crushed the pieces of food and thus helped the stomach to digest stuff more easily. The dinosaur used its terrible hands to dig and pick up food from trees and the ground. But the strangest part of its body was its back and tail. The bones at the end of its tail were joined into a single structure called a pygostyle. This thing supports the feathers of modern birds. Now, it's possible that the Dinochirus waved its tail like a fan, and its back had thick bone spikes that stuck up from its spine. Considering that those bones were covered with skin, the whole strange skeleton structure looked like a sail. You know how dinosaurs evolved to have such a strange shape and probably ask yourself, hey, what's the point? Well, scientists believe that the ligaments coming out of the spine help support the dinosaur's heavy belly and legs. To better understand how that could work, imagine cable-stayed bridges. Long vertical beams have many cables that hold the roadway. Similar, the Dinochirus spikes and ligaments help to hold the dinosaur's weight. Now, back at our dino party, it would be a shy, tall dude who accidentally drops a drinking glass and makes you feel awkward. It's lonely. It dreams of finding friends. And it will surely find them. A diplodocus would make a great buddy. A herbivorous dinosaur with 2 fingers that looks like a predator and a horse-like giant with 2 long arms show us how diverse dinosaur evolution can be. T-Rex, Velociraptor, Diplodocus, and others are the superstars of the ancient world. It would be cool if paleontologists could discover new dinosaur species that would remove the old guard from their pedestal of fame. Would you like to see a movie starring the Dinochirus and the Duonicus? Hey, I would.
You decided to go scuba diving for the first time. The water is clear and the sun is shining on the seabed. You take a few selfies and the fish swimming by when suddenly the ocean goes pitch black. You look up and, oh my, what is that gigantic animal? It's definitely not a shark, not a whale. Is it A turtle? Yup, but fear not, it's not gonna hurt you. If you had lived on this same Earth about 72 million years ago, then maybe this could have really happened to you. Scientists have recently found the fossils of a gigantic marine turtle that could have grown as big as 12 feet. If you don't have any idea of how big that is, let's see some examples. That's the average length of a hippopotamus, 6 golden retrievers, or 2 Michael Jordans stacked on top of each other. The turtle's scientific name is an homage to that old-school sea monster called Leviathan. Maybe you remember this from old-school history lessons. The Leviathan is supposedly a mythical creature that would swallow entire ships or people that were deemed too greedy by the creature. Can you imagine being swallowed by this humongous sea turtle? No, thank you. The fossils of this gigantic creature began to be excavated between 2016 and 2021, all the way in northeastern Spain. The first fossil was located by a hiker in the Spanish Pyrenees, and it was around 8 inches long. The pelvis of this turtle alone measured around 35 inches. It would definitely be one of the biggest turtles today if it hadn't gone extinct. FYI, the largest living sea turtles today can reach up to 6 feet in length, which is already pretty big. Now, how about a gigantic prehistoric scorpion? I bet most people here are not huge fans of these creatures, especially since they're poisonous, which is why the thought of a 9-foot-long aquatic scorpion might be the stuff of nightmares. Let's just say that if they hadn't gone extinct some 400 million years ago, lakes and rivers would be much more dangerous places for humans today. These gigantic insects were considered to be apex predators in their time, hunting everything from fish to other animals, even of their own kind. Yikes! I got goosebumps just imagining these creatures. Should we thank the asteroid that hit our planet now or later on in this video? Another prehistoric animal that would shock humans if it were still alive is the so-called Megatherium, a gigantic sloth. This huge sloth is believed to have grown up to 20 feet long, and its weight could be up to 8,000 pounds. It was found in the woodlands and grasslands of South America. The creature used to stand on its 2 feet in order to reach leaves on high branches. These giant sloths had huge claws. They helped them climb trees. I gotta say, I feel uncomfortable imagining these elephant-sized sloths climbing trees. Oh, of course, some dinosaurs will make our super-sized creatures list. But before that, here's a fun fact. Did you know some dinosaurs are still alive today? Scientists have proven that birds are classified as theropod dinosaurs. Such infamous creatures as the T-Rex and Velociraptor belonged to this group. I'm sure you've heard these names even before you watched Jurassic Park. The Velociraptor is that scary dino that breaks into the kitchen. Well, they evolved, gained some feathers, and turned into various species of birds we know today. That means that any bird from chickens to those little blue ones is a direct descendant of dinosaurs. Now, does the name Spinosaurus ring a bell? You can see this huge dinosaur in some museums today. Its fossils, I mean. The Spinosaurus was one of the biggest land predators to walk Earth. Actually, to walk its land and water, since scientists believe that this dino was semi-aquatic. It fed mostly on meat, which means humans would be its natural prey if it lived today. This meat-eating dino lived around 90 to 100 million years ago. It was about 60 feet long, 12 feet high, and weighed up to 22 tons. Its head was around the size of 8 bowling balls and was shaped like a crocodile's face. Basically, the Spinosaurus was a big African elephant with the face of a crocodile. Just kidding. But that would look funny though, wouldn't it? A much more attractive dino was this guy. It's considered to be the largest dinosaur that has ever lived on our planet. What made it so big was its extremely long neck and very long tail. You wouldn't want to stand behind this creature, believe me. If it decided to swish its tail, you'd get catapulted very far away. This creature lived around 100 million years ago, and its fossils were first found in Argentina around 2012. The dino measured 120 feet from head to tail, which made it almost as big as an American football field in width. And have I mentioned it weighed almost as much as a space shuttle? A staggering 75 tons. If it had been a carnivore, it would have probably been the greatest predator. But this big guy was a peaceful herbivore that had such a long neck that it could eat leaves from high trees. Cute, right? We must also talk about the Shastasaurus. As the name suggests, this animal is popularly known as the Mount Shasta lizard. Even though it was a marine reptile and probably never set foot on the mountain itself, this dino was usually around 23 feet long, but there was a specific strand of this species that could get as big as 69 feet long, about the size of the great blue whale. This made it the biggest marine reptile to have ever lived. A fun fact about the Shastasaurus is that scientists believe it didn't even have teeth, which means it could only feed on soft-bodied prey, such as squid, for example. The next animal on our list is the blue whale. Believe it or not, the biggest living animal on Earth actually started small. These days, the average mature blue whale can reach up to 100 feet in length and weigh up to 200 tons. That's more or less the weight of 40 elephants put together, or 30 Tyrannosaurus rexes, or 2,670 average-sized people. Blue whales have to eat up to 50 million calories per day to support that body. That's the equivalent of 30,000 Big Macs, just FYI. But blue whales weren't always this big. They actually evolved from a four-legged mammal that lived on Earth around 48 million years ago. Their ancestor was called Pakicetus, and it was only 6 feet long. Here's a fun fact. To be able to live in the water as one does today, the blue whale had to go through some intense adaptations. A blue whale can replace up to 80 to 90% of oxygen in its lungs each time it takes a breath. A human replaces only up to 15% for comparison. It allows these animals to dive for up to 1 hour at a time, down to a staggering depth of 330 feet. Elephants were bound to make the list. Elephants are currently the largest land animals on Earth. They can grow to be about 13 feet tall and weigh up to 7 tons. That's pretty small if we compare it to the other animals that once lived on Earth, right? But if we placed a 6-foot-tall human next to an elephant, we'll see it's not at all that small. African elephants are bigger than their close relatives, Asian elephants, and they have a similar lifespan to humans, up to 70 years. Pokemon might have made us collectively wish that salamanders were real-life dragons, although they're not. They can still be pretty cool, though. There's a giant species of salamander that is known to be the largest living amphibian. They can grow to be as long as a regular-sized human, reaching up to 6 feet. I bet that wouldn't be a pleasant underwater encounter.
It all started out as an ordinary working day for Gary Johnson, who was driving his excavator at a quarry in Oxfordshire. He was clearing the clay when, all of a sudden, he hit a bump. It turned out to be a huge footprint, and no animal from today could have possibly left it. Then, Gary noticed another huge footprint, just 10 feet ahead, and then another one. He soon realized those could be dinosaur footprints. And he was right. There were a total of about 200 huge footprints from 166 million years ago, or the middle of the Jurassic area, crisscrossing the limestone floor. Scientists started digging at the location in June 2024. The longest trackways they found are around 500 feet long. It wasn't the first major discovery in the area. Back in 1997, they found 40 dinosaur tracks nearby while digging in a limestone quarry. This time, the team took 20,000 photos of the new prints and made 3D models using flying drones. In total, there were 5 pathways at that site. 4 of them were made by sauropods, which were huge plant-eating dinosaurs that walked on all 4 legs. Their footprints kind of look like giant elephant prints, only way bigger, because these dinos could grow up to 60 feet long, about 2 times as long as a London bus. The 5th track might have come from a megalosaurus, a carnivore. Its footprint looks like the kind you'd see in a cartoon. It's called a tridactyl, which means it has 3 big, clear toes. Hey, just like me. Kidding. Unlike previous dinos, these guys could walk and even run on there too. Back then, the area they lived in was like a warm, shallow lagoon, and these dinosaurs squished through the mud, leaving their footprints behind. The footprints can help us learn how fast the dinosaurs moved, how they walked, how big they were, and what kind of environment they lived in. You can't learn all that from bone fossil records, which makes this discovery super important. Scientists think that a big storm helped save the prints in such great condition. It could have dumped a lot of mud on top of them, keeping them safe from being washed away. Just several months after the Oxfordshire discovery, scientists found over 260 matching dinosaur footprints more than 3,700 miles apart on different continents, in Brazil and in Cameroon. When they studied these prints, they realized they were about the same age and shape and came from the same type of land and plate tectonic contexts. Northeastern Brazil and what is now Cameroon in Africa is one of the last tiny land bridges where dinos could cross between the landmasses freely before the continent of Gondwana broke away completely, around 120 million years ago. Africa and South America started drifting apart around 140 million years ago, and the South Atlantic Ocean slowly filled the gap between them. As the land split, big basins formed, and rivers and lakes began to fill them up. The footprints were found in those very basins, on both sides of the ocean. Most of the prints were made by 3-toed theropods, which were meat-eating dinosaurs. But there were also prints from sauropods and ornithischians, who were herbivores. The plants in those river valleys fed the plant eaters, which helped build a whole food chain. And the muddy ground helped preserve the dinosaurs' footprints, just like in England. The latest footprint discovery, this time in the Scottish Isle of Skye, helped scientists learn something new about the dino habits. So far, they've found more than 130 footprints at Prince Charles Point. And it turns out that huge meat-eating dinosaurs and their plant-eating prey shared the same water here 167 million years ago. Some of the tracks were made by megalosaurs, meat-eating dinosaurs that were early relatives of the T-Rex. Others were from huge, long-necked plant-eaters. Some of them were 3 times bigger than an elephant. The scientists looked closely at the footprints to figure out how the dinosaurs walked and moved around. They believe the dinosaurs were hanging out near shallow freshwater lagoons, just like animals today gather around watering holes. Another important discovery from the Isle of Skye is 2 super rare fossils that are helping scientists rewrite the whole evolution of mammals. Some shrew-like creatures today live just around 1 or 2 years, right? Well, those little guys used to stick around for 7 years or even longer. Scientists found 2 nearly complete skeletons of it on Skye. One was a grown-up and the other was a young one. To figure out how these animals lived and grew, scientists used high-tech X-ray scans to look inside the rock and check the teeth, kind of like counting tree rings to find out how old the tree is. The younger creature was still changing to adult teeth, but was already about 2 years old, which is very unusual for small animals. It lived in the area during the Jurassic period, when Skye was warm, tropical, and full of shallow seas and thick forests. Back then, these tiny and strange early mammals were just starting to appear in a world ruled by dinosaurs. But they were the beginning of the long line of mammals that would one day include cats, whales, and humans. Scientists are learning about the final days of dinos from a new fossil site in Argentina. Most of what we know about the impact of that dramatic asteroid hit comes from North America, where T-Rex and Triceratops once lived. But now, we get to see what happened further south. The team of scientists working in a local quarry found bones from hadrosaurs, which are pretty rare in South America. Long ago, this desert area was warm and full of plants like ferns and palms. There was a stream flowing through wide, flat lands, which helped bury and preserve the animals that lived there. Back in 2020, scientists were exploring the area when a paleontologist found a dinosaur foot bone. They kept looking even through heavy rain and discovered a whole group of fossils, not just from one dino, but from several of different ages, maybe even a whole herd. Another super important discovery here was a tiny mammal jaw with 5 teeth found just 2 hours after searching the site. The jaw came from a small plant-eating mammal. These creatures were about the size of a chipmunk and had very special teeth with ridges and grooves for chewing plants. This was the first time a mammal jaw had ever been found in that whole area, and it made scientists realize the site could tell them more than just dinosaur stories. The team also found a tooth from another dinosaur and a claw from a smaller predator. All the fossils found here could help answer some big scientific questions, like were the dinosaurs already slowly disappearing before the asteroid hit, like they probably did up north? And what happened to the animals that survived the asteroid hit? Several years ago, scientists found another fossil, this time encased in amber, that came back from a time when dinosaurs walked the Earth. The world looked very different, but it also had some surprising things in common with today. Back then, the night skies were also lit up by glowing fireflies, and the dinos probably watched them like we do. The amber is 99 million years old, and this special firefly is only the second one ever found from the Mesozoic era. Finding these kinds of fossils is really hard, because fireflies have soft bodies that don't turn into fossils very well. That makes it tricky for scientists to figure out exactly how and when these beetles started to glow. But now, thanks to the newly found firefly, they believe the glowing started at least 100 million years ago. The fossil helps fill in the gaps in the evolution of fireflies and their ancestors. It shows that important parts, like their glowing bellies, have stayed the same since the middle of the Cretaceous period. So, let's consider velociraptors as pets. Yeah, walking your dino in the park, playing fetch, and we probably could have it now if it hadn't been for those pesky asteroids. To be fair, we ended up with mammals, which, let's face it, it was a pretty solid trade. But here's the big question. Why didn't reptiles make a grand comeback? Why did mammals rise instead? The answer, believe it or not, involves fungi. Yup, the same stuff that gives you athlete's foot and ruins your leftovers also wiped out dinosaurs. Welcome to the weirdest twist in extinction history. It all started with a very bad day 66 million years ago, when a 9-mile-wide asteroid crash-landed in what's now Mexico. This space rock was moving so fast that it vaporized on impact, punching out a crater 10 times its own size. Now, if you remember anything from your physics class, and no judgment if you don't, high speed means high energy. And that energy turned into a blast wave and heat so intense it could have cooked anything in the area instantly. And it didn't stop there. Tiny molten rock beads rained down globally, generating radiation equivalent to 20 million megatons. Forests caught fire, wildfires raged across continents, and the sky filled with soot and sulfuric acid. Earth turned into a planetary air fryer. Then came the blackout. With all that debris in the atmosphere, half of the sunlight couldn't reach the surface, making sea surface temperature drop by 13 degrees Fahrenheit. Within just a few weeks, the planet entered a literal impact winter. There was no sunlight for at least 2 years, and Earth experienced a 15-year-long climate collapse while the dust slowly cleared. 75% of all animal species completely disappeared. Those that survived the initial blast faced tsunamis, starvation, and the collapse of entire food chains. If you were a big animal, say over 55 pounds, your chances were basically zero. And if you were a plant, forget about it. No sunlight means no photosynthesis. And that means no plankton, no trees, no grass, and eventually no herbivores, which means no carnivores either. It was a domino effect straight into extinction. The Earth became a cold, dark graveyard. But there was one organism that looked around and said, "Yeah, this is perfect." And it was fungi. Now, fungi thrive in moist, dark, and decaying environments. You know, like a world blanketed in ash full of dead trees and rotting animals. With no sunlight and plummeting temperatures, fungi had a once-in-a-lifetime chance to take over. And they did. Fossil records show widespread fungal contamination in the period after the impact. It was a global fungal bloom, like the moldy icing on an apocalyptic cake. Now, this was great news for fungi, but terrible news for reptiles. See, fungi aren't just harmless mushrooms. Many are pathogens, and they love cold-blooded creatures. Reptiles, including some of the dinosaurs that survived, were ectothermic. This means that they relied on external heat sources to warm their bodies. In a normal situation, a nice sunny rock would do the trick. Bask in the sun, raise your internal temperature, and fight off infections. It's like an induced fever, because, unlike mammals, like me, their bodies don't do it for them. And yes, I'm a mammal too. But, there was no sun, remember? And a cold reptile is a sluggish reptile. Their metabolism slows down, which might sound like a good thing, because it means they can survive on less food and oxygen. But in this new hostile world, it was a disaster. They had less energy to move, less energy to hunt, and couldn't even digest food properly. Their bodies were colder, weaker, and easier for fungi to invade. Reptile reproduction was hit hard too. Most reptiles lay eggs, which are usually buried in the soil or left in hidden nests. But with the soil now damp, cold, and riddled with fungal spores, those eggs became easy targets. Spores penetrated the thin egg shells, destroying the embryos before they could hatch. So not only were adult reptiles struggling to fight infections, but their future generations were being wiped out in the nest. This vulnerability isn't just ancient history. We still see reptiles and amphibians struggling with fungi today. There's a type of fungi, hey, you try to pronounce this, that decimated frog populations. And reptiles in colder or poorly maintained environments have to deal with fungal skin infections. Which brings us to the protagonists of the era, mammals. At the time of the impact, mammals were tiny, scrappy creatures about the size of a rat. But they had a secret weapon, actually several. First off, mammals are warm-blooded, something scientists call endothermic. They produce their own body heat, and that alone gives them a major edge, because most fungi can't tolerate temperatures above 98.6 Fahrenheit. So, while reptiles were freezing and being turned into fungal buffets, mammals were literally too hot to handle. Their warm bodies acted like natural shields against infection. And then there's reproduction. Mammals carry their young inside their bodies. This means that their developing babies were safe and warm, insulated from the hostile external environment, instead of being exposed to the unfriendly world, protected just by a fragile shell. No eggs? No problem. Their metabolism was another secret weapon. Their fast-burning energy systems let them move more, hunt more, and eat more. And because they were small, they didn't need a lot of food. And here's the cool part. Mammals probably ate fungi. Yep, the same organisms ruining the lives of reptiles. And this fungal diet might have helped them boost their immune systems, giving them an evolutionary edge. Over generations, this resistance was passed down, which explains why fungal infections mostly give us an annoying rash, but still wreaks havoc among reptiles. Of course, not all dinos were cold-blooded. In fact, some massive creatures, like the T-Rex, were warm-blooded. But, warm-blooded or not, their size worked against them. You know, giants need giant meals, and in the post-impact world, those meals didn't exist. Being warm-blooded helps, sure, but not when you're too big to feed. Small dinosaurs, however, were a different story. Some survived, and we call them birds. Their small size meant they were lighter and needed less food, and their feathers helped with insulation. Being able to fly was also a flex, since they could reach food in higher places. Their beaks and guts were adapted for flexible diets, and bigger dinos were definitely picky eaters. Evolution did its thing, and the line between birds and dinos blurred forever. The same survival playbook worked for mammals. Small size? Check. Safe reproduction? Check. Versatile diets? Double check. While the rest of the world was on pause, mammals scurried through the underbrush, dodging disaster and waiting for the dust to settle. And then it did. The sun eventually came back. Plants started growing again. Life rebooted. But this time, the stage was different, with big reptiles mostly gone. No more towering predators, no more thundering herds of horned beasts. Mammals had room to stretch, and they did. They grew fast, but not too fast. Mammals never got dinosaur-sized, and that's not a coincidence. Large herbivores today, like elephants, have it easy since their food doesn't run away from them. But large predators are rare for a good reason. Hunting is hard. Your prey sees you coming, so you can't be a big, tall dummy running around. Besides, you need energy to chase, stamina to fight, and a metabolism to match. And you know how that worked out for dinos. Not to mention, mammal bones aren't built like dinosaur bones. The latter had hollow structures, even air sacs, to support their size. But if you stack too much weight on a mammal's bone, it'll snap. Nature has limits, and mammals have learned to work within them. So, when the light returned, reptiles were fewer and more fragile, clinging to the edges of ecosystems. Mammals, on the other hand, were everywhere. Before the asteroid, dinosaurs kept mammals small, and mammals, well, they didn't get much say about that. But now, with the giants gone, mammals could finally level up. And fungi? Well, they stuck around too. But mammals had already passed the ultimate test and came out on top. Thanks to their body heat, internal babies, flexible diets, and a little help from some deadly mushrooms, mammals inherited Earth. So yeah, no pet velociraptor. But maybe that's okay. You got a cat, right? Close enough. Actually, I think dogs are better. How do you feel about that? Let me know in the comments.
Dinosaurs, big ancient bugs, creepy spiders, and scary insects are all cute animals compared to the monsters that lived on Earth about 500 million years ago. For example, here's a creature that swam in the water like a stingray and had 3 eyes. Its mouth was like a pencil sharpener. 2 long claws with forked tips like pincers protruded from its head, and its gills were somewhere in the back. This is not a thing from a sci-fi movie. This is Mosaura. Its remains are preserved in excellent condition. Let's look at it more closely and study other similar monsters. The Cambrian Explosion. Remember this name. This period is also called the biological Big Bang, the time when a huge number of different living creatures began to appear in the ocean, large, small, and tiny. The ancestors of almost all modern animal groups were most likely born during the Cambrian Explosion, which lasted from 541 to 485 million years ago. It was a time when the first truly effective and terrifying predators appeared on Earth. One of them was Mosaura. It's only the size of an index finger, but you would never want to meet such a creature while swimming in the sea. It's scary to imagine what it could do with its pencil sharpener-shaped mouth. And you probably wouldn't be able to hide from it because, come on, it had 2 eyes on the sides and 1 big eye on its forehead. Mosaura belonged to a group of arthropods. Scientists called it a sea moth since it reminded them of a moth. This thing used a flap-like apparatus similar to wings to float in the water like a stingray. This monster was quite creepy, but its appearance may seem familiar because it's a distant relative of modern spiders, crabs, centipedes, and moths. Scientists found several 506 million-year-old Mosura fossils, but unlike many other similar finds, these ones have been preserved in excellent condition. The found fossils showed sharp claws, a toothy jaw, and large gills in the tail section. Some parts of the fossil were so clear that they revealed the details of the creature's internal anatomy, including parts of its nervous and circulatory systems and digestive tract. It had jointed limbs like those of modern insects and crustaceans. When this monster swam in the sea, it probably grabbed its prey with long spiked claws sticking out of its head. Many Mosura relatives have claws covered with multiple spikes, which help them grab food. But that ancient creature had smooth claws forked at the tips. That is, it grabbed the prey with those tongs, using them like chopsticks, and then brought it to its mouth. Of course, this is an assumption, and nobody saw how this creature actually did it. Unlike many other similar animals, Mosura's posterior segmented body was studded with gills. Scientists don't know why this was necessary, but they assume that such an unusual breathing system helped to adapt to an environment with low oxygen content. Perhaps Mosura led a very active reproductive lifestyle that required high oxygen consumption. Creepy, dangerous, and reproducing fast. An excellent set of qualities for one of the most dangerous predators of antiquity. But what did Mosura eat? It probably caught different types of worms and small arthropods. It's nice to think that this monster lived so long ago and was so small. But what if this creature was the size of a shark and was swimming in the ocean these days? Perhaps it would become a dominant dweller, and people would swim much less along the coast. Mosura lived in the water but was discovered in the Burgess Shale rock formation in the Canadian Rockies. Many mountains on Earth were once the seabed inhabited by strange creatures. One of them was Opabinia. It had 5 eyes, a mouth facing backward, a long trunk and claws instead of a nose. Wait, what? It's too strange even for science fiction, even for outer space. In its eccentricity, Opabinia was perhaps the loneliest creature on Earth. Scientists couldn't find another species that would be similar to this individual until recently. Meet Utaurora. It seems to belong to the same species as Opabinia. Its inch-long body was divided into 14 to 15 furrows. Each of them ended in a pointed flap. Opabinia had the same body, but it's unlikely that both monsters were friends. The difference between their timelines was several million years. It's hard to imagine why these monsters needed such strange body structures. Why haven't modern filmmakers used the design of those animals to create cool space monsters yet? Okay, they were creepy creatures, but what about weird and kinda useless ones? Scientists have discovered Su, a legless creature with no head turned inside out. Huh? This 444 million-year-old creature was found in South Africa, north of Cape Town. They called it Su after the discoverer's mother. In fact, it's some kind of new arthropod species that may have lived in low-oxygen waters. This creature was turned inside out, and the outer shell with the legs and head was lost. Thanks to mineralization, muscles, tendons, and even Su's intestines were preserved on the fossil. It's a great success to find such detailed remains of an ancient creature. However, scientists still can't determine the evolutionary history of this species. They're sure that it was a primitive marine arthropod. Okay, we can see that 500 million years ago, Earth was filled with creepy monsters, which fortunately are now extinct. But what about trees? Were they the same as we see now? Or was there something else? Something creepy? Oh yeah. Scientists have discovered a new kind of living organism similar to a tree or a mushroom. It was gigantic and had a very minimalistic design. Meet the Prototaxites. It's basically just a big stick with a round end poking out of the ground. It was smooth, didn't have the usual tree bark, and looked more like a mushroom without a cap. but scientists have recently found out that it wasn't a mushroom at all. Prototaxides probably belonged to a previously unknown branch of life. Prototaxides is considered to be the first giant organism in the history of the planet that lived on land. It existed about 420 to 375 million years ago during the Devonian period. It was the time when plants began to spread across dry land, forming large forests. Over time, they began to grow leaves and form roots in the ground. Then, the first seed plants appeared. The real colonization of land began. The first arthropods, such as centipedes, arachnids, and other unpleasant creatures, began to walk among those forests. Meanwhile, the water was filled with a huge biodiversity. There was a giant supercontinent on the planet, and smaller parts began to break off it. During this period, Prototaxides towered over the land. Some of these things reached 26 feet high and 3 feet wide. It's like a 3-story house and as thick as a palm tree. But what was it? A plant? A mushroom? Algae, perhaps? Scientists discovered them in the middle of the 19th century, but only in 2007 did they conduct chemical analysis. Research showed that it was most likely a giant mushroom, but in 2025, scientists refuted this conclusion. It turns out this may have been an unknown life form that existed separately from the kingdom of fungi, animals, plants, and protists. Scientists noticed that the inner part of Prototaxides consisted of a number of tubes. There are similar tubes inside mushrooms, but the tubes of that ancient living thing branched and joined differently. They even had a different chemical composition. The main building block of mushrooms is chitin, but the Prototaxides contained chemicals similar to lignin, a substance found in the bark of trees and other plants, and its anatomy differs from the structure of any other organism known to us. What were they doing on Earth? Just chilled and enjoyed the bloom of life? Did they produce some kind of fruit, like a banana with eyes and claws? Scientists don't know. What if it was something that was brought to Earth from outer space? What if they were flowers planted by another civilization? What do you think?
Now this bad boy was the size of a husky and could maybe pass for one, except it didn't have any fur and was a top predator with extra long blade-like canine teeth. Ooh, charming. Meet the earliest known saber-toothed animal to have ever lived. It roamed the Earth well before the dinosaurs. Scientists made the description of this creature based on its fossils found on the Spanish island of Majorca in the Mediterranean Sea. About 200 million years ago, none of us were around then, the very first true mammals appeared, and they lived right alongside the dinosaurs. But if we trace the family tree of mammals even further back, we'll find an ancient group called Therapsids. They didn't look like mammals we have today, but they had some key features that would eventually help define mammals. For example, Therapsids had special openings on the sides of their skulls for jaw muscles, and parts of their jaw bones would later evolve into the tiny middle ear bones that all mammals, including you, have today. So, the new discovery is what might be the oldest known Therapsid fossil. The fossil, which doesn't have an official species name yet, belongs to a group called Gorgonopsians. Those guys are more closely related to mammals than they are to any other living animals. Some of them were as small as cats, and others were as massive as polar bears. Gorgonopsians had some very mammal-like traits, like different types of teeth for different jobs. But unlike mammals, these ancient predators kept replacing their teeth, even their giant saber-like canines, over and over during their lives. Hey, that would be handy. Until now, the oldest Gorgonopsian fossils we knew about were around 265 million years old. But this new fossil is even older, dating back between 270 and 280 million years. The find was super detailed and complete, including its sharp knife-like fangs, part of its jaw, pieces of its spine, ribs, tailbones, and toe bones, plus most of one of its back legs. Even though the creature's skull wasn't complete, the scientists think it was about 7 inches long, and the animal itself would have been around the size of a medium-large dog, weighing between 66 and 88 pounds. But other than that, it didn't really look much like a dog. Even though it had some lizard-like features, Calling it a lizard dog is totally wrong. Mammals and reptiles do share a super ancient ancestor from about 320 million years ago, but their evolutionary paths split a long time ago. When the newly found creature was alive, the island of Majorca was right in the middle of the gigantic supercontinent Pangaea. Back then, this area went through super wet and super dry seasons. Scientists have always wondered if major moments in mammal history happened in tropical places like this, but we just didn't have the right fossils to prove it. Now, with the discovery of the oldest known Gorgonopsian in Majorca, the missing pieces of the puzzle are coming together. It looks like some huge steps in mammal evolution could have happened in low-latitude environments we haven't explored much yet. The so-called gap in the fossil record might just be because paleontologists weren't looking in the right spots. Our hero of the day wasn't the only cool guy rocking the planet before dinos settled in. Over 500 million years ago, the weirdest predators to have ever existed ruled the oceans. The name is a bit tricky to pronounce, so I'm not going to. Okay, it's Anomalocaris, but it just literally means unusual shrimp. This creature looked nothing like anything alive today. Scientists think it was the first true apex predator, the orca of its time. Anomalocaris was massive for its era, as it grew up to 3 feet from its sharp grabbing arms to the tips of its tail fins. For a while, everyone thought trilobites were its go-to meal, but new research shows it wasn't strong enough to crack open trilobite armor. So instead, it was a speedy, agile hunter with awesome vision, and it often picked off soft-body animals that zipped through the open water. Now, another really cool creature from pre-dino times is a fish that could walk on land. Tiktaalik lived in marshy rivers that looked a lot like today's Amazon rainforest. It could grow up to 9 feet long, and it found its prey in rivers and inlets like a modern-day freshwater crocodile. It had a flexible neck and even some early versions of lungs, and thanks to them, it could survive both in water and out of it. Why fish like Tiktaalik started moving toward land about 395 million years ago is still a bit of a mystery. Around that time, the ancient supercontinent called Gondwana was drifting closer to the land that would become North America. This slow movement created lots of shallow, swampy habitats, which were perfect places for crocodile-like animals to thrive. Plus, these areas were near the equator, so they were warm and tropical. But there wasn't a lot of food waiting for them on land, so maybe they moved there for safety reasons. There were fewer predators and better spots to lay eggs there compared to the water. Creatures first adapted to living in open water, then shallow water, then marshes and river edges, and only after a long, slow transition did they finally step fully onto land. Now, how about a millipede the size of a small car and weighing as much as a large dog? This beauty lived over 300 million years ago in what is now England. Back then, during the Carboniferous period, Earth's atmosphere had way more oxygen, over 26%, compared to today's 21%. Scientists used to think the high oxygen levels were the only reason these creatures could get so big. But back then, they found a new fossil from a time when oxygen wasn't that much higher than today. They discovered it purely by accident, when a boulder split just right and revealed one of the most complete and largest giant millipede specimens ever. This one could have lived not just in swampy areas, but also in open woodlands filled with tasty seeds, nuts, and maybe even small animals. There's a chance that this beast wasn't a slow, plant-munching crawler, but a predator that would snap up whatever it could find. After dominating the Earth for about 45 million years, the giant millipedes eventually vanished. Probably the reptiles pushed them out, clearing the way for the age of the dinosaurs. Now, in case you ever wondered what would happen if you crossed a polar bear with a saber-toothed cat, here's the answer. This guy ruled the southern ecosystems after migrating 7,000 miles across the supercontinent Pangaea around 252 million years ago. It had a tough skin like a rhino's and massive canines, perfect for tearing away huge chunks of meat, and it was an excellent runner. Once it got to its new home, in what is now South Africa, it replaced a whole group of local predators. But its glory didn't last long, as closer to the end of the Permian period, massive volcanic eruptions made the weather patterns change and wiped out about 90% of all species. And because top predators are usually big, slow to grow, and not super common, they often vanish among the first when massive extinction events hit. And that's how our guy here went extinct. Our final creature of the day was a dragonfly that lived around 300 million years ago and had a wingspan of over 2 feet, 6 long, spiny legs, and huge, bulging eyes. Meganjura. This 4-winged giant is most likely the largest flying insect that ever lived, and it easily outsizes today's dragonflies, which are its distant relatives. Like modern dragonflies, Meganjura like to hang out in open areas near ponds and slow-moving streams. But unlike today's dragonflies, it wasn't just catching tiny bugs. This guy was likely the top predator in these open spaces. It used the spines on its legs like a flying trap to snatch prey out of the air, including other flying insects, small amphibians, and even lizard-like creatures. Scientists found the first fossils of Meganjura in 1880 in the coal-rich rocks in France. The fossils were incredibly well preserved and showed off the detailed vein patterns in their wings. Scientists think Meganjura grew so huge because it didn't have much competition from vertebrates, and the air back then, during the Carboniferous period, had a lot more oxygen than it does today. So yeah, a giant asteroid fell to Earth and destroyed all dinosaurs with a blast wave. That's what we've all heard. It was a terrible disaster, but it was actually much worse. You can't even imagine how unfortunate it was for dinosaurs and what kind of disaster they faced. It wasn't just a piece of solid rock from space, but a lump of molten clay. It provoked not just a tsunami, but giant mud waves. It filled the atmosphere, not only with a burnt smell, but also with an acidic and foul smell of rotten eggs. It didn't just sweep everything away with a blast wave. It provoked a volcanic winter, poisoned the air, and blocked the sun. And do you know what the most unfortunate thing was? If the angle of the fall had been just a little bit different, or if it had fallen a little further away, then there might not have been any global catastrophe. That asteroid, the size of Mount Everest, fell in the coastal part of the Yucatan Peninsula. This place separates the Gulf of Mexico from the Caribbean Sea. The asteroid touched both solid rock and water and immediately triggered strong tsunamis and mega ripples. These are large sand waves that are normally about 3 feet long on average and leave a pattern similar to dunes on the seabed. Oh, by the way, they're really called subaqueous dunes. So when the meteorite fell, it formed 52-foot-high mega ripples. Can you imagine? Giant waves of sea mud that are almost as high as a 5-story building. But how did the scientists figure it out? They used 3D seismic data and modeled the mega ripples pattern in the program. The data was based on the landscape of the bottom, which was impacted 66 million years ago. First, a powerful strike triggered a strong earthquake that liquefied the seabed layer, and then a high-grade tsunami triggered those mega ripples. That is, while giant waves on the surface flooded the land and went into open waters, large mud waves destroyed the seabed. Ancient fish, dinosaurs, and other underwater creatures didn't stand a chance. But what does this information tell us? Well, first, studying the effects of ancient tsunamis helps to reconstruct the past of our planet. Secondly, it helps us to be prepared if something like this happens in the future. Predicting a scenario like this could save countless lives in case of danger. Okay, there was a total mess in the water at the time of impact. But what was happening on land was much, much worse and scarier. But let's discuss the meteorite itself first and what it consisted of. The scientists analyzed the rocks at the impact site and saw traces of carbonaceous chondrites. This is the rock that makes up most of the meteorites in space. Often this rock contains water, clay, and organic compounds with carbon. It means that, in a sense, a lump of dirt the size of the highest mountain on the planet fell on Earth. And yes, carbonaceous chondrites often have an unusual smell of rotten eggs, tar, or wet hay. So it wasn't just very loud, but it also probably smelled bad. It was a fetid rocket on a planetary scale. However, at the time of the fall, not a single living creature was there to sniff it. All of them lost their lives in the first seconds of the disaster, hit by the devastating blast wave. It set a chain of events that later wiped out all the dinosaurs from the face of the Earth. The peninsula where the meteorite fell turned into a large crater in an instant. Thousands of tons of soot and ash were released into the air. A huge area was filled with thick smoke. The sky turned gray. Black clouds obscured the sun. But wait, where did the ashes come from? The crash site contained huge reserves of flammable materials. In simple words, the meteorite fell into a giant barrel of fuel which started to burn. The sky remained dark. Grass, plants, trees, and bacteria couldn't get enough sunlight. The green world began to wither. And this affected not only the impact site, but almost the entire continent. Even dinosaurs, living far away, felt the low temperatures and lack of ultraviolet light. Dinosaurs couldn't survive in such conditions. The environment was changing too fast. Then it got even worse. A firestorm was spreading in all directions from the place where the meteorite had fallen. The air inside the storm was poisonous and dangerous to inhale. And you know why? Because the meteorite fell in a coastal area and destroyed the seabed. And under that seabed, there were large reserves of sulfur. This toxic mass rose into the air, mixed with ash, soot, red-hot pieces of rock, and meteorite particles. Then the winds picked up this cloud and began to spread it across the continent. The rainforests that survived the blast waves were still in danger, as the hot toxic cloud rained down red-hot ash upon them. This caused large-scale fires. The smoke from the burning trees rose and became part of the destructive cloud. The more trees burned, the larger and thicker the poisonous ash cloud grew. What could have stopped this catastrophe? Rain clouds filled with water, right? Good point, but they didn't. When the hot ash and sulfur fumes mixed with water, they created acid rain, a downpour of poisonous, corrosive mud that wiped out all life around it. Fires, firestorm, acid rain, sun blockage – how could dinosaurs survive after that? Where could they escape? Perhaps the ocean shore? Bad idea. Yeah, the water could have protected them from the fire and ashes, but there was another problem. Do you remember mega ripples and giant tsunamis? A huge wave that hit the shore at that moment could easily wash away New York. Smaller waves rolled across the Atlantic Ocean and the North Pacific. So, if dinosaurs on land had tried to hide near the shore, they would have been swept away like specks of dust by that giant tsunami. But what about underwater dinosaurs? They were not affected by the tsunami and the fire cloud, but they were trapped. Red-hot poison particles of ash and mud fell into the ocean in huge quantities and poisoned the water. Algae and phytoplankton were destroyed. Because of this, millions of fish lost their food supply. And as a result, larger fish and marine dinosaurs were left with nothing to eat. Large-scale famine triggered extinction in the ocean. Toxic particles poisoned the water for many marine life forms. The gills of fish couldn't extract pure oxygen from the water, which only worsened the situation. Near the Yucatan Peninsula, the ocean floor with its coral reefs and ancient sea creatures was destroyed. This huge part of Earth's biodiversity disappeared, upsetting the balance of the oceans. Of course, the destruction couldn't go on forever. At one point, the ashes cooled and settled to the ground. The sulfur cloud dispersed, the fires went out, and the air became clearer. Warm rays of sunlight began to shine down on Earth again. But there was something sinister about the silence. The planet no longer heard the rustle of pterodactyl wings, the roar of a hungry Tyrannosaurus, and the noise of a velociraptor's fast feet. The storm had passed, along with the dinosaurs. By the way, some flying lizards and small animals survived. Later, they evolved into modern mammals and birds. It wasn't the meteorite that destroyed dinosaurs. Fires couldn't do it either. Dinosaurs disappeared because of the famine caused by the catastrophe. Disruption of the food chain, led to the mass extinction of these magnificent lizards. After the catastrophe, life began to blossom again. However, the emergence of large mammals was still a long way off. But now, millions of years have passed. Large elephants, rhinos, and other animals walk on Earth, along with the most unique mammal on the planet, the human. This day isn't different than any other. Well, not yet anyway. You crawl out of bed, your hair's a mess, a huge yawn stretching your jaws. 5 more minutes and you could be late. So, no time to waste. You blast through your morning routines, skip breakfast, throw on your jacket, and hurriedly close the door. Bang! Darkness. You slowly blink your eyes open. The air smells different, making you feel dizzy. Your ears catch something similar to a dino movie soundtrack. Once you glance around, though, you realize it looks like a prehistoric world too. It's humid and warm. Everything around you looks green and lush. You spot several creatures moving among the trees. Some of them have bills that make them look like overgrown ducks. Others have horns. That's when your brain kicks in. Those are dinosaurs. So you have indeed somehow moved all the way back to prehistoric times. Right after the realization hits, you feel something tickling your arm. With a feeling of dread, you sneak a peek. What is this creature comfortably nestled on your sleeve? What you notice first is that it's tiny, way smaller than your cat. It's likely napping on your pillow back at home in the moment. Picture a hummingbird, the smallest bird on Earth. The creature on your sleeve is even smaller than that. Is it some weird prehistoric insect? Nope, it's a dino, the tiniest dinosaur that ever lived. The creature's called oculodentavis, which means in Latin, eye-toothed bird. With a skull that's less than 1/4 of an inch long, the animal itself is about 2 inches long. You can hardly feel its weight on your arm. The tiny thing doesn't weigh more than an ounce. The dino is obviously a meat eater. It has more than 100 microscopic teeth. They're conical with sharp edges. For a second, you can't breathe. What if it bites you? You don't even know if the thing is venomous. But it looks as if the dino bird is only interested in insects that are flying by. The creature also has huge eyes. They're so large it's a bit alarming. They face to the sides and bulge out of its head. They're built in the way that makes it clear the tiny dino is active most during the day. If only there was a scientist next to you. They would tell you how such a minuscule creature could exist in the prehistoric world of giants. It was likely because of the miniaturization. That's when relatively large animals became smaller over generations. It sometimes happens to species that live on islands or are isolated from other animals. Another thing an expert could tell you, the creature sitting on your arm might not even be a dino. After scientists examine the ancient animal's skull, or should we say will examine, they suggested it was not a dinosaur, but a lizard. But even if their guess is right, it was a bizarre lizard. After all, it has a bird's head. Anyway, whatever the animal is, you are tired of standing still trying not to disturb it. But as soon as you take a step, everything goes dark again. Bang! You cautiously open your eyes. Another day, another jungle. You look around to check your surroundings, and that's when you notice that several massive bushes on the left have started to move. You know you should probably run away as fast as you can, but your curiosity wins. You sneak up closer to have a look, and your ear-piercing shriek is heard miles away. The creature you're looking at is similar to a millipede, an enormous 6-foot-long millipede, the largest among them all. It's called Arthropleura. Scientists aren't sure why this bug, like many others, was so large 300 million years ago. Maybe because there was too much oxygen in the atmosphere, 30% of the air then versus 21% now. It probably helped prehistoric insects grow so massive. Plus, there was nothing around that could eat them. The only comforting thought that doesn't let you pass out from sheer horror is that the monster isn't likely to be a meat-eater. It's related to millipedes, and they eat decomposing organic matter. Yum. You hardly have some time to take a breath when something swooshes past you. You realize it's time you got used to scary overgrown creatures. This flying one looks like a dragonfly, but its wingspan is no less than 2 feet. Scientists claim it's been the largest known insect of all time. The craziest thing, though? The insect looks exactly like a scaled-up dragonfly, but it actually belongs to the now extinct order of griffinflies. But what's that? Instead of flying away, the not-a-dragonfly is turning back. It's moving toward you. Paralyzed by fear, you don't even try to run away. Bang! Darkness. Well, this is getting old. You open your eyes and see a dark shadow towering over your lying body. This is definitely a dino. You even know its name, the Stegosaurus. These large dinosaurs lived during the late Jurassic period, around 150 million years ago. They had absolutely amazing plates placed along their spine. The largest were more than 2 feet tall and 2 feet wide. Stegosauruses were heavy, massive, and clumsy. They grew more than twice as tall as an adult person and weighed about 5 tons. At the same time, this huge body was controlled by a tiny brain. It was twice smaller than the brain of a modern dog. It was one of the reasons why the dinosaur was such a slow thing. Some experts claim its maximum speed was no more than 5 miles per hour. Now, before you have time to get afraid, you realize the creature isn't interested in you whatsoever. But what an impressive plant-eating machine it is! With the help of its toothless beak, it's nipping low-growing plants like pines, firs, and cycads. But soon, you understand you shouldn't let your guard down. A dark shadow covers the sky. Ah, you know this guy too. That's a pterodactyl. It was the first discovered species of pterosaurs, large flying reptiles. The pterodactyl walked on 4 legs and, unlike some other members of its family, it had teeth. By the way, even though pterodactyls were flying creatures, they weren't ancestors of modern-day birds. Those descended from tiny meat-eating dinosaurs that walked on 2 legs and were covered in feathers. Anyway, the creature circling in the air over your head doesn't look as frightening as in the movies. It's rather small, with its wingspan no more than 3 feet. But to be on the safe side, you decide to hide under the trees. Hey, you've been around pigeons. Imagine a present from this character. Never mind. It's just your luck to trip over a tree root while retreating to the questionable safety of the forest. Your back hits the ground. Bang! Darkness. Well, when you come around again, you find it hard to breathe. It feels as if something's wrapped around your body. You raise your head, slowly and cautiously. Is this day gonna end? A colossal snake has coiled itself around you. The creature's so large, you immediately realize it's the Titanoboa. No other reptile, living or extinct, can be that big. The snake weighs more than a ton and is probably around 42 feet long. For comparison, one of the largest modern snakes, the anaconda, weighs 1/4 of a ton and reaches the length of 30 feet at the most. The Titanoboa lived around 60 million years ago in South America. Just like modern anacondas, it loved damp places hidden in tropical rainforests. Scientists aren't sure, but they think the prehistoric reptile could live in or near the water. Then it probably fed on crocodiles, turtles, and even fish. Suddenly, you feel the snake move. Is it going to squeeze tight around you? That's when you start to regret you can't do that time jump thing at your whim, and then, bang, darkness. You find yourself on the bank of a wide river. Once you get closer to the water, you notice something moving under the surface. You lean down to check what it is, but the next moment you spring back in fear. The 2-foot-long fish you see has a single row of triangular razor-sharp teeth, each serrated like a steak knife. It's the mega piranha. Now, be extremely cautious. This creature packs a terrifying bite. Its force is almost 30 times the piranha's weight. And on average, this creature weighed 20 to 30 pounds. For comparison, its modern version doesn't grow heavier than 2 pounds. The mega piranha lived 6 to 10 million years ago in South America. Well, too long ago and too far away from your home. You sit down on the ground farther away from the river and begin to wait. Sooner or later, there will be the already familiar boom and the darkness. It'll mean your adventures will continue. Then you remember that strange-tasting burrito you had for dinner last night. Could there be some connection?